Welcome to The Explainer. Today, we're diving into something, well, pretty mind-bending. It's a new theory, straight from the Ariano papers, that questions the very fabric of reality. The idea that everything we see, everything we experience, might just be the tip of the iceberg. So let's kick things off with a huge question, one that philosophers and physicists have wrestled with for centuries. Think Plato's cave, but for the 21st century. What if our entire reality is just a shadow? A projection of something much, much deeper. All right, to get our heads around this, here's the plan. We'll look at this shadow reality idea, see what problems it's trying to solve, define the real four-dimensional territory, and then see how it totally rewrites the rules for gravity and life. And finally, we'll ask what this all means for science itself. Let's get into it. All right, first up, a shadow of reality? This is the core proposal, and it's a big one. The main idea here is that our familiar 3D world, everything we can see and touch and measure, well, it's just not the whole story. So get this. The theory says our 3D world is just a projection, a shadow of a complete, static, four-dimensional reality. Forget about the universe evolving moment by moment. Instead, I want you to picture a giant, unchanging 4D block. This block contains everything that has ever happened and ever will happen. The past, the present, the future. It's all there, simultaneously. Our sense of time passing? That's just our consciousness moving through this block, kind of like a spotlight illuminating one slice of it at a time. The whole thing already exists. Okay, so why even come up with an idea this wild? I mean, a static 4D universe? Well, it turns out this framework starts by tackling two of the absolute biggest mysteries in all of science, cracks in our current map, if you will. So on one hand, in the world of physics, you've got this massive headache called dark matter. It's this invisible stuff that supposedly makes up 85% of all matter, but we've never, ever detected it directly. And on the other hand, over in biology, we have Darwinian evolution, which hinges on random chance being the main driver of all the incredible complexity of life. Now, what if I told you these two completely different problems are actually the same problem? That's what this theory suggests. They're both just symptoms of us looking at a shadow, not the real thing. And here's a huge piece of evidence. Take a look at this map of the universe. When you plot everything we can see, stars, galaxies, you name it, by its mass and its size, you get these weird, forbidden regions. It's like there are invisible walls in the cosmos where things just can't exist. Now, why would that be? The theory says a fundamental reality shouldn't have arbitrary rules like that. These boundaries, they're a clue, a geometric fingerprint, really, suggesting that our 3D space is kind of squished inside a larger 4D structure. So this all leads us to the central metaphor of this entire framework. It's all about understanding the difference between the map and the actual territory. Okay, so this deeper four-dimensional reality has a name, counterspace. Just think of it as the whole content of reality. It's static, it's complete, it's not going anywhere, it just is. And the flow of time that we experience every second of every day, that's just an artifact. It's the result of how our 3D consciousness slices up this much bigger, static 4D reality. And this is where it gets really interesting for how we think about science. On the left, you see the territory. That's the real deal, the complete 4D counterspace, the source of everything. And on the right, that's the map. That's all of science. Every law, every equation, every observation we've ever made. It's just our best attempt at drawing a map of a territory we can't ever see in its entirety. So, okay, great analogy. But how does thinking of the universe as a map actually help us solve a real-world problem like dark matter? Let's get into rewriting gravity's rules. This is the absolute key. Theory says we can stop looking for dark matter because it's not a thing. It's not some exotic particle we have to find. The effects we see are caused by missing information, not missing matter. It's a geometric effect, the way that 4D geometry gets projected or flattened onto our 3D space. So instead of adding new stuff to the universe, we just need a new law that describes that projection. And bam! This new law isn't just a vague idea. It makes an incredibly precise prediction. Just look at this chart. That dotted line is what our current theories of gravity predict for how galaxies should spin. As you can see, it's way off. But the solid line? That's the prediction from this new framework. It nails it. It perfectly matches the observed rotation of galaxies with absolutely zero dark matter required. That's a huge deal. But wait, there's more. It's not a one-trick pony. The exact same law also predicts the effects of gravitational lensing, the way massive objects bend light. Again, look at the chart. The solid lines are the framework's prediction, and they line up perfectly with the data. And remember, lensing was one of the key pieces of evidence that made us think dark matter had to exist in the first place. Okay, so this idea seems to solve the dark matter problem pretty elegantly. But this is where the theory gets, well, even more ambitious. It takes this exact same map versus territory logic and applies it to biology, to life itself. The claim here is just as radical. Darwinian chance, that randomness we think drives evolution, it's an illusion. It's another artifact of our limited perspective. The paper calls it a foliation artifact, which is just a fancy way of saying it's something that only appears to be random because of the specific way we're slicing through that higher 4D reality. And this table just lays it all out so clearly, it's a perfect parallel. In physics, our limited 3D view creates the illusion of dark matter. In biology, that same limited 3D view creates the illusion of chance. The concept being eliminated is different, dark species in one, chance in the other, but the underlying logic is exactly the same. So think about what this means for evolution. It's not a random meandering walk through time anymore. It's more like we're just seeing different slices of a pre-existing 4D geometric sculpture of all possible life forms. The blueprint for a dinosaur and the blueprint for human were always there, encoded in this higher dimensional geometry. Our history, the fossil record, that's just one particular path we've taken through this vast, timeless biological landscape. So, what's the big picture here? What's the takeaway? If this is even a little bit right, it doesn't just change physics or biology. It fundamentally changes what it means to do science. Right now, a lot of science is based on falsification. You come up with a theory, and then you try your hardest to prove it wrong. If a prediction fails, the theory's out. But in this new view, science becomes more like cartography, like map making. The goal isn't to find the one true theory and prove it right. The goal is to continuously draw a better, more detailed map of a territory we know we can never see completely. A failed prediction doesn't mean your theory is wrong, it just means you found the edge of your current map. And that means a failed experiment isn't a failure. It's actually a moment of profound discovery. The paper makes this incredible comparison to a Gödel sentence, something that's true but can't be proven by the system you're using. When an experiment doesn't match our theory, it's like reality is handing us a clue. It's a discovery of a geometric truth that our current map just wasn't sophisticated enough to include. Which, of course, leaves us with one last massive and kind of awe-inspiring question to ponder. If all of science for all of human history has just been us drawing a map, what does the territory truly look like?